I'm going to log out because
somebody just joined.
Okay, well, thanks for the folks who have joined. We'll probably wait another minute here for some other folks to join. Looks like we've got a few people, but we've got quite a few more registered, so let's give them some time to jump on here. Okay, I guess we'll get started. Hi, everyone. Thank you for joining. My name is Tim Ade. I'm the Business Development Director for Encryption Consulting. I'll be your host for today's webinar. And as you see, the topic is protecting secrets in your IAM environment. We have two presenters today, one from Encipher and one from Encryption Consulting. Their names are Michael Cherokee and Puneet Singh. Puneet, you want to take it from here?
Thank you, Tim. Guys, I want to give you a little bit background about the Encryption Consulting LLC. We are a startup and we focus in the space of the PKI, HSM, encryption, code signing, and data masking. We have 30 plus customers in the Fortune 500, and we normally focus on the consulting business. Mike, do you want to go ahead?
Sure. My name is Michael Cherokee. I work for Encipher Security. Encipher Security is an Entrust data card company. And a little bit of our history, we've been in the business of building hardware security modules for over 20 years, since the mid-1990s, when we decided to invent a better mousetrap. And our security world architecture is our claim to fame. And we are a market leader now with long history of certifications and validation. We have deep expertise, as you can see, and a track record in applied cryptography. Our motto is trust, integrity, and control. You can see that in the middle, and the idea is that at some point in our world, we have to have a root of trust. That root of trust can be housed in a secure hardware environment called a hardware security module. And that provides not only the trust model, but integrity and control as well. Next slide. And so what I'll do now is discuss our agenda. I'm going to present a little bit about HSMs, and I'm not going to go real deep. I'll take about 15 minutes, and I'll be talking about what are the HSMs, what do they do, where do HSMs and PKI fit into an identity and access management architecture. In other words, why are we talking about identity and access management? And then where do we use HSMs in a secure PKI? You'd be surprised at how many places it actually fits. Puneet's going to talk about PKI pretty much. What is it? What does it do? What are the use cases? What are the different options and modules? The different components of PKI that can be integrated with an HSM, as I mentioned above. And then, you know, how do you design a PKI with the cloud, and what are the best practices on PKI? So that's our agenda. We're going to take anywhere from 30-35 minutes between Puneet and myself, and after that we're going to open up the floor for questions if you have them. Next slide, please. So what are HSMs and what do they do? So hardware security module provides a foundation of trust. It is a certified platform. The main thing that happens here is it generates cryptographic keys, and it does that very, very well. In a hardware security module, we actually have not one but two hardware-based random number generators, as opposed to software-based pseudo-random number generators, which are some, you know, in terms of cryptography, somewhat easy to crack. And that initial random number is extremely important. The use of HSMs to protect private keys is considered a best practice in a number of applications, and in many certified or where you have industry certification requirements, the use of HSMs to protect your cryptographic keys is a requirement. It's not an option. So it is the highest level of protecting your encryption or signing keys. You can implement and enforce defined policies. There are a number of, you know, and you'll see in a little bit where we integrate with a large number, well over 100 partners in the security world that actually integrate with our HSMs to protect their secrets. What these guys won't tell you, in a way, is, you know, they have very secure applications, but when the application is running in software, which could also be in an appliance that is running software, that appliance is generally not hardened like an HSM is hardened and certified hardened. And so in order to meet certain regulatory requirements like FIPS 3 or common criteria, that hardening has to take place. And so the integration with an HSM actually hardens the applications that are integrated with that HSM. So you might have a level 2 application that runs just fine, but the keys are at risk. And so in order to protect those keys, you can store the keys in an HSM and bring that up to a level 3 certification level. So as I mentioned already, it's a source for high quality random numbers, which is an extremely important thing for you to have. Next slide, please. And this slide is what does an HSM do, and really it doesn't do a lot of things. It's a really short list, and it's a really long list at the same time. But again, it generates those strong encryption and signing keys with large random numbers that are true random numbers. We sign and verify data and certificates. We also encrypt and decrypt data with the HSM. And then, as I mentioned, we are a hardened appliance that's hardened against virtual or network-based attacks, and it's also hardened against physical attacks. So if you try to, you try to drill a hole in it, you try to take out a screw, you do things like that, it'll what we call, it'll tamper the device. that actually disables the device and destroys it. It cannot be recovered. You need to return it to us, and if you have maintenance, we'll replace it. But that's its job, is to sort of commit suicide if anybody tries to tamper with it. But that is really what it is, and you know, sometimes I scratch my head and look at this, because signing and verification of data and certificates is simply an application of encryption and decryption of data. So in a way, you might even say there's only three things. So the next item on the agenda is, next slide please, is where do HSMs and PKI fit in an identity and access management architecture? This is my favorite slide because there's nothing for you to read. I'm setting you up because the next slide is actually a kind of an eye chart. But I'll tell you how I came up with that eye chart. First, a little background on me. I spent 4 years as an identity and access management architecture, which is part of why they asked me to come make this presentation today. And I was sitting here scratching my head, and I thought, yeah, I couldn't think of anything. Kind of fits everywhere, but you can't just say, oh, it fits everywhere. And so I went to one of my favorite places to get ideas, and one of everybody's favorite places. I went to Wikipedia. Next slide, please. And in Wikipedia, I looked up identity management, and also known as identity and access management. And down at the bottom in wiki articles, you don't have to read this, by the way. If you want to, just go to Wikipedia and look it up. Those are all links. I just took a picture of the links. There's 40, at the bottom of these wiki articles, they have links to see also. And same here. And they have 44 related articles in Wikipedia that have to do with identity and access management. So my problem wasn't that I couldn't come up with an idea. My problem was, it's like there's so much stuff. There's all these things, and then I actually went through all of these, and you can pick them, identity management systems, mobile signatures, service provider, dongles, loyalty cards, RBAC. I'm just picking them out randomly. I'm looking at the screen while I'm doing this. All of these things can be backed up by a public-private key pair, of which the private key is stored in an HSM. And when you have, in these 44 verticals right here, when you have a public-private asynchronous key pair, you need to distribute the public key somehow, and public key infrastructure is the way that we do this. So moving on to the next slide. I mentioned that we have over 100, and this is just a few of the partners of security solutions that we integrate with at Encipher. So and all of these places, a best practice, if you implement these in any kind of an environment that requires regulatory compliance, best practice is always going to be protect the key in a hardware security module of some sort. And if you look around, we call this our wheel of fortune. We like to say that because that's what it looks like. So you go around and, you've probably seen one or two of these names like Microsoft, Oracle, Encryption Consulting. I see them down there. CyberArk, F5, Palo Alto. I'm not picking anybody because I like them better. It's just because I happen to see their logo. But we have all of these customers integrate with HSMs and integrate with Encipher. So this is our strategic, technology partner program, and we cover the gamut from encryption and database security, digital signing, payment security, credential management, PKI, of course, code signing, key management, privileged access. All of these things are absolutely part and parcel to any identity and access management platform. The big players in there, you'll see CyberArk, you'll see CA, and their key factor, Microsoft, of course. We integrate with Red Hat. Next slide, please. This is where identity and access management applies basically everywhere. Okay, all of these things apply in an identity and access management. I actually thought about that real hard. I thought, well, payment security. Well, payment security is all about identity and access management. The security analytics, well, yeah, that does too. Of course, the cloud, lots of stuff is moving to the cloud, credential management, code signing, digital signing, integrity. And the next slide, please, is where does IAM apply to, or where does the PKI apply here? And what it is the PKI applies in all of those different places. So again, you have asymmetric encryption involved in all sorts of aspects of privilege, identity and access management, whether it's signing and verification, hashing, validation of certificates, one-way ciphers, all sorts of things, tokenization, that was the word I was looking for. All of these things that apply and are built into identity and access management and privileged access management. And whether it's user certificates, user identities, or machine identities, all of these things utilize the certificates that are issued and managed by a public key infrastructure. So next slide. The next slide here is where the HSM use cases in a PKI exist. Offline route, issuing CAs, those are the obvious ones. Online routes. If you have an online route, I would not recommend that, by the way, but that's why we have Puneet coming up. Policy CAs, registration authorities, OCSB responders is a big use of HSMs and validation authorities. And so there's actually many different places where HSMs will integrate to a PKI, making your PKI a trusted source or a trusted route for all of your identity and access management needs moving forward. And this is where I turn, at the next slide, I turn things over to Puneet. So
Thank you, Mike.
away.
Thank you, Mike. That being said, in this particular section, I will discuss more about the PKI, and we'll talk about use cases, and the hot topic is that, like, how should we move our PKI to the cloud? We'll discuss about that as well. That being said, the first question in the room is that, why do I need a PKI? The main thing is that when you're dealing with the internet, you don't know what is the party you are talking to or who you're working with on the other side of the internet. So PKI kind of provides the identity to the users and the machines over the internet. And in simple terms, PKI is all about providing an infrastructure to an organization to address the different security issues such as authentication, encryption, digital signing. And if we think from the CIA triad perspective, that what are the problems the PKI solves? So the PKI provides the users the confidentiality, integrity, authenticity, as well as the non-repudiation. Now, in simple terms, if we think from the PKI perspective, that what are the different components at high level which are involved in the PKI, then they are certificate authority, Active Directory, and the applications. This particular slide is more tied towards the Microsoft PKI, but the concept remains the same even if you are using the open source EGBCA. The certificate authority plays the major 4 roles. It kind of validates that who is actually requesting the certificate, and it also issues the certificate. The third major role which it plays is that it is involved in the revocation of the certificate, which I normally consider the most important function of the certificate authority. The fourth role which it plays is that of extensibility. And when I say extensibility, there are 2 modules which are involved in the certificate authority, the policy module and the exit module. The policy modules comes into a picture whenever we request a certificate. It kind of set the rules to be followed for a certificate to be requested. And the exit module comes into the picture once the certificate has been issued. Now, Active Directory kind of acts as a registration authority in the PKI and acts as a source of truth, kind of validates that whether this user or the resource exists within the organization or not. The last component, which are the applications, are kind of consumers of the PKI, and they use to get the certificates from the PKI and then do the validation and everything. That being said, the main thing the user uses from the PKI is the certificate. In the simple terms, if we talk about a certificate, it's kind of a equivalent to your driving license. It's acting as your identity over the internet, as your driving license has a issue date and who has issued it, as well as the date from where to when it's valid. Similarly, in the certificate, you have a serial number of the certificate. You know that which certificate authority like GoDaddy, Thote, who has issued that certificate to you. And then you also have the serial number which acts as a unique for that particular certificate. That being said, whenever we are designing the PKI, there are different options which are available for designing for the trust models. You can either go with a 2-tier PKI or the 3-tier PKI or the 1-tier PKI. There's no right or wrong answer in the designing the trust model. I normally recommend to my customers that to start with a 2-tier PKI and then decide that whether that 2-tier PKI solves their problem or not. And then they can either go for the 3-tier PKI or for the 1-tier PKI. Now, question arises that what will be the scenarios when I will be using a 3-tier PKI and when will I be using the 2-tier PKI? Normally, the most common use case, which I normally suggest to my customer, that if you're outsourcing your PKI infrastructure to a third-party company who's going to issue or control your issuing CA, it's always better to go with the third-tier PKI or the 3-tier PKI. But if you're running the PKI within in-house, it's better to go with the 2-tier PKI. Now, it's not that those are the only 2 models or the 3 models which are common there. But if you want to have a one root CA and on one side you want to have a 2-tier PKI and the other side you want to have a 3-tier PKI, you can still have it. The root CA will be common, but the policy CA will be tying back to the trust of anchor, the root CA. Whereas on the 2-tier PKI, the issuing CA will be tying back to the trust of anchor, the root CA. Now, there are 2 ways to do the certificate validation. First way to do the certificate validation is using the CRL. In the case of the CRL, what happens is that there's a file which is being published by the certificate authority, and whenever an entity wants to validate its certificate, it checks against it. It's just against that particular file to check that whether their serial number is present on that revoked list or not. And they kind of sequentially pass that particular file. The second method, which is there for the validation, is the OCSP. In this case, you kind of get a binary answer, yes or no, whether your certificate is valid or not. Now, as the word says that online certificate status protocol, I would like to bring to your notice here, guys, that if you're using the Microsoft PKI, the information which you're getting from the OCSP server is not a real time. What happens is that in the case of Microsoft PKI, the OCSP server kind of caches the CRL from the CDP points, and it's not kind of a real-time information, because if your CRL is not getting refreshed every minute, you're still getting a stale information. And second thing is that the client which is getting the response from the OCSP server, it kind of caches that response at its endpoint, and it doesn't goes back to the certificate to the OCSP server for validation for each and every time. There are other drawbacks as well, which are there with the Microsoft PKI OCSP server. But if you're using the commercial OCSP servers, those don't have all these problems which are present with respect to the Microsoft OCSP server. Now, this particular slide kind of lays out the high level concept which Mike was also talking about, that what are the components which normally ties back to the HSM. So if you look into your enterprise, if you're looking at there are different components in the PKI such as root CA, issuing CA, network, device, enrollment service, OCSP server, and they have their own private key or the master secrets. And as per the best practice, you have to type all those to the HSM hardware security module so that you can get the best security for all those master secrets or the private keys. Now, nowadays, the biggest hot topic is that if I have a PKI, how can I move my PKI to the cloud? And this particular right-hand side, I have tried to showcase that what would be the best practice that if you want to build your PKI in the cloud and specifically using the Encipher HSMs. So here, what I have tried to showcase is that you will have a root CA on premises and you can have a policy CA also on the premises, and both the keys of the root CA and the policy CA will be protected by the Enshield Edge and the Encipher and Shield Connect HSM. And then you can have one issuing CA on premises, which will be handling the request of all the certificates within on-premises devices or the users and everybody. Whereas you can have an issuing CA in the cloud as well, which can give the responses or issue the certificates for all the components you have in the cloud. And Encipher has a service called Encipher Cloud HSM, which is kind of a HSM as a service, which you can tie back to your issuing CA in the cloud. Now, if we talk about some of the common challenges, what I have seen while doing the assessment for different organizations, that top challenges what they face. The first challenge what I have seen is that people don't pay attention to their CDP points, CRL distribution points, and sometimes they miss to issue the CRL on time, and that's where they got the certificate outages and everything. Other challenges what I have seen is that, which is really common, is that when people are not aware about the HSM, that what critical role it plays in securing the private keys in their environment, they just go with the software-based cryptography for their PKI, which is pretty easily to break. Normally in the Microsoft PKI, if you're not using the HSM, it uses the DAPI APIs, and it's just a setting in the registry. There's a utility which is available on, there are various utilities which are available online, which you can use to break the lock of the DAPI APIs, and anybody can walk away with the keys. And that's where the HSMs comes into picture. There are other problems also. What we have seen commonly is that people don't do a due diligence that what trust model will work best for them. And then once they have designed the PKI and the certificates are out all over the network, it's really tough to go back and fix the problem. The other challenges are with respect to the disaster recovery, as well as with updating their CPCPS as well. That being said, I will try to wrap this session with some of the PKI best practices. As I said earlier, try to store all the critical keys of your PKI infrastructure, such as your root CA, issuing CA, NDIS, and OCSP keys into the HSM, and try to run the PKI view.msc every morning and see that your all CDP points are active and everything is green. Especially with the scenario what we are running with the COVID-19, if you are doing your due diligence with the PKI view.msc and ensuring that all the CDP points are green, it will make your PKI run healthy. The other things I would say is that when we say that your root CA has to be offline, it has to be truly offline. Don't create a virtual machine which can be turned on at any time. And try to have a frequent updates to your CP and CPS at least once in a year, or maybe 2 times in a year. That being said, we at Encryption Consulting can help you provide training in the PKI space, or if you guys have any health check or need any help with the design and implementation, we are more than happy to help you guys. Mike, do you want to add something?
Sure. Thank you, Puneet. Yeah, right at the top there, storing all root CA, issuing CA, and as an OCSP private keys into an HSM. And in the world of identity and access management, as I said before, probably the first place you need to start is a secure PKI, and the only way you can make a secure PKI is by marrying all of those private keys into an HSM. And as Puneet said, you know, if you don't do it right the first time out, it's really difficult to back into it. Generally speaking, the correct way to do it is just build an entire new PKI, you know, and then migrate your certificates over from the old PKI into the new one. So it's easier and cheaper to do it right the first time. But that's really where you start, and then with all of your identity and access management needs, tokenization, privileged access management, you know, protecting your secrets all over the place. Now you have a secure basis for your IAM architecture. I might point out that while you're doing this, the HSM is not just for PKIs. It'll directly integrate to a number of other things. So now I'd like to open up for questions. If you have any, we'll, you know, but I think our presentation is over for now. I see that the question has been asked, what is the difference between a certificate policy and a practice statement? That's a question for Puneet.
So certificate practice statement is that what actually you do day to day, and certificate policy statement is kind of a high level at your organization level. How would you be laying out your PKI? And normally there's an RFC 3647 which provides the details about it. And if we know the user who has asked us, I can send you guys the detail, more detail on that as well.
I don't see any other questions. Tim, would you like to wrap it up?
It helps if when you unmute yourself, huh?
There you go.
Sorry about that. Thank you everybody for attending. If you have any other questions, you see here are the contacts. Puneet's emails on here, and as well as Jeff's email, so feel free to use that. And we appreciate your time. We'd be glad to address any questions you have, and if you'd like to talk further about any challenges you're facing during COVID-19, and we all know how important it is working remote these days, we'd love to help you. So that's a wrap.
Okay, thank you guys.
Thanks everybody.